In the present video, we will discuss the introduction of assignment problem. Let's see the definition of assignment problem. Suppose there are n jobs to be performed and n persons are available for doing these jobs. Assume that each person can do each job at a time with varying degrees of efficiency. Let's see ij is the cost if the ith person is assigned to the jth job. Let's see the example. Here 3 jobs to be performed by 3 persons and consider each person can do each job at a time with varying degree of efficiency. Let's see 1 is the cost of first person for the first job and C12 is the cost of first person for the second job and C13 is the cost of first person for the third job. Similarly, C21, C22, C33 are the cost by the second person for the performing the jobs 1, 2, 3. Moreover, C31, C32, C33 are the cost by the third person for performing the jobs 1, 2, 3. Now question is, which job is assigned to which person for minimizing the cost? So these type of problems we are calling as the assignment problems. So the problem is to find an assignment. Which job should be assigned to which person on a 1-to-1 basis, which means one person doing the one job at a time, so that total cost of performing all the job is minimum. So these problems of this kind are known as the assignment problems. An assignment problem can be stated in the form of n by n cost matrix, that is Cij of real numbers as given in the following table. Here n jobs to be performed by the n persons with the cost Cij. So this is the cost matrix and represent the by a square matrix like this. Some examples of the assignment problems is workers to machines and salesmen to different sales areas, clerks to various checkout counters, classes to rooms, vehicle to routes, contracts to bidders, etc. So these are the examples of the assignment problems. Next to see the mathematical formation of an assignment problem. Here objective is minimize the assignment cost. So mathematically assignment problem can be stated as minimize, that is summation of I equal to 1 to n and summation of j equal to 1 to n Cij xij, where I equal to the number of persons, that is I equal to 1, 2, 3 up to the n, and j is the number of jobs, that is j equal to 1, 2, 3 up to the n. Here subjected to constraints are xij equal to 1 when the ith person is assigned to the jth job. If it is not, we have to consider the xij value is the 0. Similarly, two more constraints, that is person's point of view as well as job point of view. First we have to see the person's point of view, that is j equal to 1 to n summation of xij equal to 1. So this is the person's point of view. So here one job is done by the ith person. Similarly, job point of view also, only one person should be assigned to one job. So summation of j equal to 1 to n xij equal to 1, only one person should be assigned the jth job. So here xij denotes the jth job is to be assigned to the ith person. So there are two types of assignment problems. One is the balanced assignment problem, another one is the unbalanced assignment problem. So when the number of rows equal to the number of columns, respected type of assignment problem we are calling as the balanced assignment problem. So if it is the given problem is a square matrix, we have to say that one it is the balanced assignment problem. In the square matrix, obviously, so number of rows equal to the number of columns. So number of persons equal to the number of jobs. This type of problems we are calling as the balanced assignment problem. Second one is the unbalanced assignment problem. Here number of rows is not equal to the number of columns. In general, solution methods of assignment problems are, we are following the different methods, that is the enumeration method, simplex method, transportation method and the Hungarian method. In the most of the conditions we have to apply the Hungarian method. Then next we have to see the what is the differences between the transportation and the assignment problem. So first difference is for the transportation and the assignment problem. In the transportation problem, number of sources and destination need not be equal. Hence the cost matrix is not necessarily a square matrix. But in the assignment problem, since assignment is done on a one-to-one basis, the number of sources and destinations are equal. So number of persons should be equal to the number of jobs. Hence the cost matrix must be a square matrix. Second difference is the Xij, that is quantity to be transported from the ith origin to jth destination can take any positive value and it satisfies the rim condition. But in the assignment problem, Xij, that is jth job is assigned to the ith person and can take either the value 1 or 0. So third difference is the capacity and the requirement value is equal, that is Ai and the Bj for the ith source and the jth destination. So in the assignment problems, the capacity and the requirement value is exactly 1 for the each source of each destination. The capacity and requirement value is exactly 1. And last difference between the transportation and assignment is, in the transportation problem, the problem is unbalanced if the total supply and total demand are not equal. But in the assignment problem, the problem is unbalanced if the cost matrix is not a square matrix. So these are the differences between the transportation and the assignment problem. Next we have to see the Hungarian method, which is generally using for the solve the assignment problems. In the Hungarian method, we have to solve in the two phases. First phase is row and column reductions. Second phase is optimization of the problem. In the first phase, that is row and column reductions, two steps we have to perform. First step is subtract the minimum value of each row from the entries of that row. And the second step is subtract the minimum value of each column from the entries of that column. In the second phase, that is optimization of the problem, step 1 is draw a minimum number of lines to cover all the zeros of the matrix. This can be done by the row scanning as well as the column scanning. Let's see what is the procedure for the row scanning. In the row scanning, we have to start from the first row and we have to ask the following question, that is there exactly 1 0 in that row? If yes, so if having the only 1 0 in the particular row, then I have to mark a square around that 0 and draw a vertical line which is passing through that 0. Otherwise, skip that row. If the row having the more than 1 0, then I have to skip that row. And after the scanning of the last row, check whether all the zeros are covered with the lines. If it is all the zeros are covered with the lines, then no need for the column scanning. Directly I have to go for the step 2. Otherwise, I have to go for the column scanning. Let's see what is the procedure for the column scanning. In the column scanning, we have to start with the first column and ask the following question. Is there exactly 1 0 in that column? If the yes, mark a square around that 0 and draw a horizontal line passing through that 0, otherwise we have to skip that column. And after the column scanning, in the last column we have to check whether all the zeros are covered with the lines or not. So second step is check whether the number of square marked is equal to the number of row of the matrix. If yes, then directly have to go for the step 5. That is, we have to consider that solution is the optimal solution. Otherwise, we have to go for the step 3. So third step is identify the minimum value of the undeleted cell value. Then we have to add this minimum undeleted cell value at the intersection points of the present matrix, and also subtract the minimum undeleted cell value at the undeleted cell values, and remaining all the values should be the same only. Then you have to go for the step 4, that is the go to step 1. Once again you have to go for the row reduction and column reduction, and the row scanning and the column scanning. Then I have to draw a minimum number of lines which have to cover all the zeros. Once again I have to check whether this number of square marked is equal to the number of rows. Then we have to consider this solution as marked by the square one. That respected square cell we have to consider the optimal solution. So this is the general procedure for the Hungarian method. So thank you.